Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Last episode we added a bunch of boxes to the level. However, in order to open them up we will need to shoot them with Duke's CIA prototype nuclear pistol. So in today's episode we are going to spend our time implementing shooting. Let's start blasting. First what we need to figure out is the graphic for our bolt, or laser beam, or whatever it is. So I think it's in the object sprite sheet, so let's figure out which sprite it is that we need to render. So I'm opening up the object sprite sheet here, read object, and then converting it to a sheet, and then image IO write to a PNG, new file object PNG. Okay, so let's take a look. Here we have our laser beam graphic. So that is 0, 1, 2, 3, 4, 5. That is graphic number 6. And it is animated with 4 frames. So let's go ahead and create a new class. We'll call it bolt, I guess, or laser. I guess bolt is okay. Let's extend active because we need X and Y, and we need a render method and the update method and stuff. So we'll just reuse that. A bolt is flying either to the left or to the right. So we need to have a facing. And I think I'm okay with overriding the update and the render method. So render, we can just do renderer draw tile, and then we set assets get object 6 x y. And for the update method, we can just update our x with our facing. And then either left we are -16 because a bolt travels 16 pixels per frame. Speaking of frames, it was animated, so let's just keep a frame counter here. And let's increment this 6 by frame so that we get the next one in the animation loop. And then here, increment frame by frame +1. Make sure we don't exceed 4. Okay, so this should be a good start. Then let's add these bolts to our game state. So private list bolts. Import the list. Create an instance, empty list, new array list, get bolts. And here we should update the bolts as well. So we'll just do bolts for each bolt. Update. Oh, that's the wrong update. I need to do the bolt.update. Bolt.update this. And then in the renderer function, let's also render the bolts. So let's do that after we draw the level. So we can do game state bolts for each bolt.render this assets. This should draw the bolts. So now we should add bolts to the screen. We should add bolts to this list when we shoot. So in order to shoot, we need to be able to press a key. So let's go ahead and add the fire key. And let's make the control button the fire button. And then here we can say is fire. In the main class, let's use it if we're pressing it. Then we'll just tell Duke to fire. And then here, I think we should just set a we don't have access to the game state. I guess I'll just pass it in for now. State get bolts, add new bolt, and then we'll just take in Duke's X, Y, and facing values. And then back here in the main class, we need to pass in the game state because we're referring to the same instance everywhere. Okay, so now I expect Duke to be a full automatic machine gun laser beam fire. Yeah. If you hold down the button, he just draws all these lasers. Okay, so obviously Duke is not able to have unlimited amounts of lasers on the screen in the normal game. You shoot the laser beam, and then depending on your firepower, you can shoot again. So let's first implement the firepower that Duke has. So let's go to the Duke class and let's add firepower. Private int firepower. Duke's firepower. Select none in the. I guess we'll just assign it here. It's not a big deal. So Duke's firepower starts at 1. You can shoot 1 bullet at a time. So let's, I don't know, let's put the firepower getter here. Get firepower. So first let's display the firepower in our heads up display. Health, here's the firepower. So let's draw image assets, get object. So we should draw the gun. So let's figure out where is the gun. So the gun is there. And then we should count the amount of objects. Okay, so that is object number 43. 43. And X and Y position is 264, 94. And null. So this is the gun. And then for int I equals 0, I equals state Duke firepower. And here we'll just draw bolts. So graphics, draw image, assets, get object. So the bolt was 6. And then we need to have our X position. So that is base location plus power I times 8. Each isn't it supposed to be 16? I guess we'll see. I think it's 16, man. 16. And then null for the observer. Okay, so let's see if it draws a single firepower. There it is. So let's quickly put Duke's firepower to 4. It's the maximum in the game. Stop and rerun. Okay, but then I think it's more appropriate to also offset the object in the HUD with the animation frames. Yeah, okay. These are the different graphics. All right, fine. Okay, so now that we're displaying the firepower and we have a variable for the firepower, we can use that to check our fire, because we are only allowed an X amount of bolts to be active at one time. So as long as we haven't fired more than our firepower, then we can add a new bolt that flies across the screen. Now this means that we need to remove these bolts when they are off the screen. Now we don't currently have a way for a bolt to know if it's on the screen or not, but we do know if we're close and like how far we are from Duke. So let's do that first. So let's update our active flag with our X. So the absolute value of our X minus Duke's X. If that is less than, I don't know, 10 times the tile size. So as long as we are 10 grid cells close to Duke. So if we're close to Duke, then we're active. As soon as we cross this boundary, we're going to flag ourselves as inactive. And then in the game state update method, we'll just remove any inactive bolts. And we should do that before we update the bolts. So remove if bolt not bolt active. So this removes any inactive bolts. So now we can only shoot one. Yeah, and we can only shoot it if it left the screen. And okay, so now that we fixed that we're not a machine gun anymore, we're a semi-automatic machine gun now. We should fix the origin of the bullet because it starts out a bit too high. And if Duke is facing to the right, it should also start out a bit more to the right. So let's go ahead and fix that real quick. So where do we spawn the bolt here? So I think we need to increment Y by 4. And then the X position should be Duke's X plus, if our facing is right, it should be the tile size, and otherwise nothing. And then we should put parentheses around this part here. Okay, so this should offset the bolt to the right if we're facing right. So left, I'm happy with this. And then right looks pretty good as well. All right, next up is to get the bolt to collide with the level. Now the naive way would be to do, state level collides with our X, Y, width and height. But in this case, that is not going to work because of the way that the original game handles the bolt. We need to do some special collision checks here because there is a solid tile that we can destroy. So we need to know which tile we're hitting, and this level collides check just returns a boolean. Plus, the bolt is traveling so fast at 16 pixels per frame. And if we're moving towards the left and we are halfway through a tile, because Duke can move 8 pixels at a time, so that means that sometimes the bolt spawns halfway in the grid, because each grid is 16 pixels. So that means that if we are halfway in a cell and then we figure out the grid location for the bolt, we would divide by 16, and then we would lose half that cell, and then the bullet would look too far to the left for the collision detection. So let me just show you what I mean here. So if we were to do this level collision like normal here, this divides X by, the tile size. So it tries to calculate the correct. So let's do Boolean solid equals this stuff. And then we say he's active if we're close enough and we're not hitting a solid cell. So this would be how you would probably do it first, but then you can see that we're flying halfway in the cell. And that's because the bullet dividing, when we're going to the left, the bullet is dividing. Yeah, there you go. There you can see it. The bullet is dividing the cell, the X value by 16, and then because it's spawning halfway in, it's not working correctly. So in order to fix that, we are going to do our own collision check. And what we will do is we will calculate our row, which is just Y divided by the tile size, and we will divide our column. We'll also start out by dividing by the tile size. But then we need to check if we have a remainder. So that means that if this operation returns something larger than 0, and we are facing to the left, because if we're going to the right, it's okay to lose precision, because then we're not looking too far ahead. But if we're facing to the left and dividing to a grid position and we're losing, 8 pixels, then we're looking too far to the left. So if this is the case, our column should be incremented by 1 to not lose this remainder value here in our grid position. And then what we can do is, instead of doing a collides check, we can just ask, hey, which tile do you have on this row and column? So this is int tile ID. And then we can just check if we have a solid at, you know, the tile ID. So let's just copy that code real quick from the level. So this is that. So the nice thing about this is that if there are some special tile IDs that you can shoot, then here you can react to that as well. So then we know, like, hey, we hit this special tile. Let's destroy it, you know? So now the code is just flying through because we are removing the bolts too late. So we need to, instead of removing them first and then updating them, we should just remove them once we're done. And let's do this in an iterator. Bolt iterator is get bolts iterator while as next. Grab the bolt, update, and then if after update the bolt is not active anymore, bolt.remove, bolt iterator dot remove. This does everything in one go. So I think this will, yeah, so now we can see the bullet spawn go halfway into the box or stop right there. So that's good. And then let's go over to the other side and see, yeah, it now behaves exactly like the original game. So that is collision for the level. Okay, so now let's do collision with other active tiles. And we will cheat a little bit here. Because what we'll do here is we will keep a hitbox. Because the other actives, they can also move freely around in the level. They are not per se snapped to the grid. So we'll just use the rectangle class here. Let's create a new hitbox. And then the width 15 and the height is, I don't know, 8. So let's go into the object.png that we wrote out earlier. Because our hitbox is of course not the entire cell here, right? The 16 by 16 graphic. It's only, you know, the hitbox should be like, I don't know, 8 pixels down. And then this area here. So I think we should increment the Y that we get in with 8, for example. And then set the height to 7, -1. All right, and then every time we update the X value, we should also update our hitbox X here. And then we'll leave this code here for now. And then what we'll do is we will public boolean hits some other active class. We'll calculate a hitbox for the other guy. Rectangle hitbox is new rectangle active, and then we'll just assume that it occupies an entire cell for now. Probably we should have that the active can give a hitbox, and then we'll just return this hitbox intersects with the hitbox from the active class. All right. So if that is the case, so let's go ahead to our box class and let's say here, if state bolts, any bolt, and we need to get the bolt, I guess, right? So what we need to do is we need to filter the bolts, and then we should say that bolt hits this. And then find the first. And then if that is present, then we hit this bolt here. So we'll say bolt dot hit, and we'll set ourselves to active as false as well. We'll inform the bolt that it hit something. And then here, I guess we can do if solid, then we'll also call the hit, else check if we should still be active. And then here, if we hit, we'll just say that we're not active anymore. Okay. So that is cool. So now a box can be active. Yep. We should remove inactive actives. So we're also going to create the same iterator here. Active iterator is state get actives get level. This is a level already, so I can just do get actives iterator while iterator has next active equals iterator next. If not active anymore, remove. Iterator remove, sorry. Okay. The loop can be replaced. Oh, I have to, of course, also do a call. Update it with the state. There we go. Okay. So now I expect these boxes to disappear as soon as we shoot them. All right. And all that is left is that the bullets should also disappear. Once it's shot, oh, we can't shoot cameras yet, of course. So here we're shooting stuff. Okay, so the bullet doesn't disappear yet, so let's see why not. So the box checks for a hit, makes himself inactive. It tells the bolt, hey, you're hit, set your active flag to false. And I'm guessing what is happening is that it enters, because we're removing after update, so it enters this update method anyway, and it concludes that it is still active here, so the active flag gets overwritten. So let's go to the game state update where we do this iteration here, and I guess we just need to check here. If we're active, then update. And this update method might change the active flag, so we need to do this in a separate if, not in an else if. And this should remove the bolts if a box tells that it's been hit. Okay, so I think this is looking pretty nice. The bullets do disappear. Okay, I think that about wraps it up for today's episode. I'm not too happy with the different types of collision checks that we have in the code now, here in Bolt, and then here we have some in level, and then the Acme sign does its own collision check here, and the box that drops down does some random collision detection. So I think we should spend some time in a future episode to really unify this collision detection and hit detection to use probably this rectangle hitbox or bounding box class in the future. So yeah, look out for that one. And for next episode, I'm planning to have these boxes that we can now shoot actually spawn the items that they contain, such as the joysticks and the footballs and maybe even the soda cans and stuff. So yeah, join me for that one. And for now, I want to thank you very much and see you guys in the next episode. Bye-bye.